on to part 2 of Unit 3-1, we're going to play with some logs here. So let's go ahead and revisit what we talked about briefly in the first lesson, is that exponential and logs are basically inverses. Well, they are inverses of each other. This is y is equal to x, and these are going to be a reflection of each other across that line. Now, if we have y is equal to bx, then log of b, this is our base, of y is equal to x. Look at the relationship here. B is the base, x is the exponent, y is the number. But this is best shown in a couple examples. Let's go ahead and dive into that using that very same example. So what we're going to do is we're going to write this in exponential form. And we're basically, remember when we solve for inverses and functions, we're kind of doing that, but not quite. Log is just a fancy way of counting. Don't forget that we use a lot of logs in real life stuff. I think you're in sciences, a lot of it used in sciences. So basically, we're just going to, this is my base, this is my b, okay? And that's going to be raised to my x right here. So this is just 4 to the third is equal to 64. That's all we're writing, okay? So this is going to be 36 to the 1/2 is equal to 6. Okay, and we'll dive into a little bit more of the mathematical history and reasoning between logs and exponents. Log actually is derived from the log books that ship captains would use in the early days of sailing. Alrighty, now we're going to now go backwards. We're going to write the exponential into log form. So what we have is an equation here. So we want to go ahead and write this into log form. Well, if you have your patterns memorized, and I've seen ways teachers teach this differently, and I'll show you a couple of them in class. But basically, once you get used to it, you're going to realize that this is my base, so this is going to be log base 5. And it's going to be of 125 is equal to 3. 125 is equal to 3. Let me show you another way to do this. We can do one side, we can do something to one side as long as we do it to the other. So I'm going to take the log of both sides, and I'm going to do log of base 5. So here we have log of base 5 of 5 to the third is equal to log base 5 of 125. Okay? Now, if you remember from your algebra course that we have this raised to an exponent, this log raised to the exponent, so I can bring the 3 into the front. That's exactly what I'm going to do. I'm going to do 3 log base 5 is equal to log 5 125. Now, this is log base 5 of 5. That's nothing more than the number 1. So that just becomes 1. All right. So that's going to be 3 is equal to log base 5 of 125. And we're done. And it's going to be the same thing over here. If you look at your patterns, you're going to realize, okay, that's going to be log base 6. Okay. And it's going to be of this right here, my y. So I'm going to do of 1 over 36 is equal to negative 2. And I could have taken the log of both sides. I could have taken I could have done log base 6 over here and log base 6 over here. I'll run through that real quick. 6 to the negative 2 is equal to log base 6 of 1 over 36. Move that negative 2 to the front. Just like that, log base 6 of 6 is going to be 1. And that cancels out, so I have negative 2 is equal to log base 6 of 1 over 36. Alrighty. So continuing on, now we're going to find each of the following. So I don't like blanks over here, but math teachers do it all the time. Just call that x, all right? Log base 3 of 27 is equal to what? That's just 3 to the x power is equal to 27. Therefore, we know x has to equal to 3. All right, 3 to the third power is 27. Now, I can have my rule memorized where we have base here, and this is the same thing. I can move that 2 to the front, call that 2 log pi is equal to x. That just cancels the 1, so x is equal to 2. Okay. Alrighty, I think that might be it for this lesson. I will pick up the next one, wrapping a couple things up in part 3.